Hello, Assalamualaikum everyone. We meet again in Physics is Fun session with me, Teacher Has. Okay, wait, I think there's too much energy in me today. Forgive me. By the way, speaking about energy, do you know how electrical energy is generated in a nuclear reactor? Not sure? Afraid not, because today we are going to learn generation of electrical energy in nuclear reactor in 15 minutes. Our topic for today is 6.2 nuclear energy and our learning outcome is 6.2.4 describe generation of electrical energy in nuclear reactor. Before we continue, let us recall the important terms in this subtopic, which is nuclear fission. Alright, nuclear fission is a nuclear reaction when a heavy nucleus splits into two or more lighter nuclei while releasing a large amount of energy. Okay, remember the keywords: fusion, fuse, fission, split. Now, let's get to know with our main character today, which is nuclear reactor. Some of you maybe already have an idea, that's good, but let's see the scientific definition for nuclear reactor. So, a nuclear reactor is a device in which nuclear chain reactions are initiated, controlled, and sustained at a steady rate. The most significant use of nuclear reactor is as an energy source for the generation of electrical power and for the power in some ships for nuclear marine propulsion. But our focus is on the generation of electrical power. Now, what you see on your screen is the structure of a nuclear reactor and the process of electrical energy generation at a nuclear power station. But why there's two pictures? What is the difference? Okay, the first one is the block diagram of the process. It is simple and everyone can sketch this one when explaining the process. And the second one is the real structure of a nuclear reactor. And in this video, I am going to use this one, the real one, to explain the process. So sit tight and pay attention. Let's get started. Okay, so this one is nuclear reactor. Nuclear reactor are the heart of a nuclear power plant. In here, nuclear fission of uranium-235 and its chain reaction produce heat energy. Okay, so this is the condenser. What happened here is water is pumped into the reactor core to absorb the heat energy that is produced by the nuclear fission. Okay, if you can see right here, this green arrow, this is the water that is pumped into the condenser, and this is the second circuit. Okay, for the pink arrow right here, this water is the radioactive water, which means the water circulation system are always kept separate from one another. Water in the primary circulation system never leave the containment building because this water is radioactive. And then this is heat exchanger. Okay, so what happened in this heat exchanger is that the boiling of water produce high pressure steam, and this steam will be channeled to the turbine. Then the turbine is rotated by the high pressure steam, which in turn rotates the magnet or coil in the generator. Then the water is circulated back into primary circulation and condensed into water. After that, the electrical energy generated is sent to consumers via a power supply transmission system. Now, we can use electricity without having to worry about the emission of any carbon dioxide. But not us, because Malaysia are not going to use nuclear energy as one of our renewable energy source. Well, not at least until we discover a way of reversing the process. This is a short animation for you to get a clearer picture. So let's watch this animation. Okay, so this is naturally occurring uranium processed into pellet. Okay, then the pellet are sealed in a metal tube. Okay, and then the fuel bundle insert into a large tank, which is the heart of the nuclear reactor. Alright, and then fission occurs, resulting in tremendous amount of heat energy. Okay, so here, heavy water slows down neutron. Okay, heavy water is used as moderator. Then, the boiling of water produces high pressure steam. Okay, it is happen here. And then this steam is channeled to a large turbine that connected to a rotor in a generator. Okay, this is the turbine and this is the rotor. Okay, the spin of the rotor producing electromagnetic field that then producing electricity. Then the electricity is sent through transmission lines to homes and businesses. Did you know where this nuclear reactor is located? Yup, at Bangi, Malaysia. Okay, this is known as Triga Puspati Reactor, RTP, the only nuclear research reactor in Malaysia. Okay, so Triga stands for Training, Research, Isotope Production and General Atomic. So we do have a nuclear reactor in Malaysia, but this reactor was designed to effectively implement the various fields of basic nuclear science and education, okay? Not as renewable energy source in Malaysia. Alright, next we are going to discuss chain reaction in nuclear reactor. Okay, so look at this picture. This neutron right here is bombarded to the uranium-235 nucleus. Okay, so why we use uranium-235 instead of uranium-238 is because it is a fissile isotope. Okay, meaning that it can split into smaller molecules when a lower energy neutron is fired at it. Okay, meanwhile, uranium-238 need much more larger energy for the neutron to split the molecules. Okay, so the fission of uranium-235 nucleus produce two daughter nuclei, which are split into one krypton 92 and the other one is barium 141. Okay, and also releasing three fast-moving neutrons with large amount of energy. Then the three fast-moving neutron released just now will bombard other uranium nuclei and release more neutron through continuous nuclear fission. This continuous reactions is known as chain reaction. Okay, but because this is a continuous reaction, until when we want it to continue? How we can control the rate of the nuclear reaction? So there are several components to control the rate of nuclear reaction in nuclear reactor. The first one is control rod. Okay, this one controls the reaction rate by absorbing excess neutron. Okay, it is made of boron or cadmium. The second one here is moderator. Okay, the function is to slow down the fast-moving neutron release so that nuclear fission can occur. And it is made from materials such as graphite or water. Okay, so the last one at the bottom here is uranium rod. It is used as fuels for producing nuclear energy through nuclear fission reaction. Then what about the safety features in a nuclear reactor? So there are two components here. The first one is the thick concrete walls. This is to prevent radioactive radiations from leaking into the surrounding. And the second one is using water as a cooling agent. Okay, water here can absorb heat energy from the chain reaction to generate steam. This can control the reactor temperature. Let's look at some examples. Okay, so write the equation for the fission of a uranium-235 nucleus when it is bombarded by a neutron. Alright, so this diagram right here showing uranium-235 nucleus, okay, bombarded by one neutron. Okay, so what it will produce is that two daughter nuclei, which are krypton 92 and barium 141. Okay, and also releasing three fast-moving neutron and also large amount of energy. So how do we write the equation for this fission? Is that we can write, okay, uranium 235 plus 1 neutron, okay, equal to releasing 1 krypton 92 plus 1 barium 141 plus 3 neutron. Okay, some exercise for you to try later on. Okay, you have to indicate whether the following statements are true or false by circling the correct letter. If the statement is false, correct it to make it true. So number 1, to control a chain reaction, control rods are lowered into the reactor core. Lowering control rod slows the reaction. True or false? Number 2, control rods regulate the speed of a chain reaction by absorbing neutrons that could otherwise cause fission. True or false? Number 3, water is used to keep the core of the reactor from becoming too hot. True or false? And number 4, fission occurs inside the reactor's core fuel assemblies in the core. True or false? Okay, I think that's all for this video. I hope to see your answer in our next class. So by now, I hope you can describe generation of electrical energy in nuclear reactor. Okay, that's all from me. Thank you for watching. Bye-bye.